Good morning, students. In previous lecture, we have discussed what is meant by compressor and what are the different types of the compressor, how it works. And now, today we are going to discuss what is meant by condenser. As we know that the basic function of the condenser is to remove the heat from hot vapor refrigerant which flow through the condenser coil. And the heat from the hot vapor refrigerant in the condenser is removed by two methods: transferring the heat to the walls of the condenser tube, and second one is the transferring the heat from the tubes to the condensing or cooling medium. Now the medium will be, you can see, we can use the air media or we can use the water media, or in both combinations we can use the uh, combination of the different types for the cooling media purposes. Now we are going to see how the condenser works. So this is the representation of the pH chart of the vapor compression refrigeration system. Now if you observe in this system, here you can see the this process is called as the condensation process. Now here you can see here we can see at point 2 to 3, this is the de-superheating region, and 3 to 4 is condensation, and this 4 to 5 is the subcooling. Now here this curve represents the water saturation line, and this curve represents you the dry saturation line. Now at point 3 there is a definitely dry steam is there, and at point 4 you can observe it is the saturated water over there. So we can see the after the condensation, the dry superheated, or we can say this is the superheated region, this is the liquid dry region, and this is the liquid region. So liquid in liquid vapor region, and you can observe here, if the steam is the superheated during the de-superheating 2 to 3 we are achieving, and 3 to 4 there we can observe the condensation process. Now superheated vapor, as we discussed during this process, is de-superheating, and superheated vapor is cooled to the saturation temperature at point 3 here. Now in the condensation 3 to 4 process, the saturated vapor refrigerant gives its latent heat, and after giving the latent heat, you can observe here, it achieves the dry saturation region to the liquid saturation region. So in the subcooling 4 to 5, the temperature of the liquid refrigerant is reduced below to its saturation temperature. So what is the effect of this de-superheating or subcooling? So we are observing that the refrigerating effect is increasing over here. So this is the condenser working. Now we are going to discuss the factors affecting the condenser. Generally, the factors affecting on the condenser is the material from which the condenser are manufactured. Second one is the amount of contact. Amount of contact means what? Up to to where what up to which contact of the these uh, vapors coming in contact with the cooling medium. And third one is the temperature difference. So in the temperature difference, the condensing media and the coolant, so water its temperature difference. So our in these three parameters: material, amount of contact, temperature difference. On these factors, the condenser capacity is depends. So next point, we are as we have discussed here these 3 points. Next, we are going to discuss the classification of the condenser. So according to the media use, if we are using the air media, then there is two types of the condenser: natural convection and the forced convection. In water cooled condenser, tube in tube, shell and coil, and forced convection. And third one is the evaporator condenser. So this is the classification of the condenser: main air cooled condenser, water cooled condenser, and evaporative condenser over there. Now we are going to discuss how the air condenser works. So in the air condenser, if you observe, the removal of the heat is done by the air, and these tubes are made up of the steel or copper tubes, and the outside diameter is varying from 6 mm to the 18 mm. Now, steel tubes are used in the ammonia refrigerant plant, and copper material we are using for these tubes because it has high transfer capacity of the heat. Now, in this air cooled condenser, the tubes are provided with the tubes with the plates. Why we are introducing these plates? To increase the surface area of the heat transfer. So there is a effective transfer of the heat over there. So fins are made up of aluminum. These are the lighter in the weight. So in the air cooled condenser, and condenser with the single row tubing provides the most efficient heat transfer. So single row condenser require more space than multi-row condenser, and single row condensers are used in small capacity refrigeration systems such as the domestic refrigerator, freezer, water cooler, room air conditioner. So the types of the air cooled condenser, as we have discussed, the natural convection condenser and the forced convection air cooled condenser. So here you can see in the natural convection, as we have discussed, the heat transfer from the condenser coil is takes by the air by its natural convection, and the heat transfer rate is the slower as require large surface area. So these type of the condenser having the small capacity, and we are using such kind of the condenser in domestic refrigerator, freezer, water cooler, room air conditioner. Now this is related with the natural convection air cooled condenser. In forced cooled convection air cooled condenser, we are definitely using the um, fan or blower. So the propeller fan, or we are saying that the centrifugal fan, is used to force the air to flow over the condenser coil to increase the heat transfer capacity of that condenser. So in forced convection, there are generally two types. First is the base mounted air cooled condenser, and second one is the remote air cooled condenser. So in base mounted air cooled condenser, propeller fans are used, and fans are mounted on the same base of the compressor, motor, and the receiver. These are mounted on the same base of the fan. So fan is mounted on the shaft of the motor, and this type of the arrangement um, used for the system which has the 10-ton capacity and the or less than 10-ton capacity. done. So keep in the mind, in base mounted air cooled condenser, fan are mounted on the same base of the compressor, motor and the receiver. But in remote air cooled condenser, in such type of the condenser located either outside or inside of the building, and it has the capacity of 10 to the 125 ton refrigeration system. So in remote air cooled condenser, they are mounted on the foundation on the ground or roof or other side of the buildings from the walls, and the propeller fans we are generally using. And this arrangement require the duct system to carry the cooled air, or we are saying the fresh air to the refrigerator air. So centrifugal fans we are using in the remote air cooled condenser. So the keep in the mind, the air cooled condenser we are classifying into the natural convection and forced convection. And forced convection again we are classifying on the base mounted air cooled condenser and the remote air cooled condenser. In the base mounted air cooled condenser, these are mounted on the same base of fan is mounted on the same base of the compressor, motor and receiver. But in case of the remote air cooled condenser, we are finding these are located outside of the building or top of the roof or side wall of these building. So the ducting system is required to transfer the cooled over air over there. So this is related with the water cooled condenser. So in the water cooled condenser, generally water is used as the condensing media, and the water cooled condenser are adopted when the adequate supply of the clear inexpensive water, availability of the water disposal, and use refrigeration unit. So why? Because we are finding it over there. So first we are going to discuss the waste water system. So in this system we are using the waste water system. So in this system we are using the wastewater vapor refrigerant from the evaporator is introduced inside the condenser, and which is converted into the hot vapor refrigerant. So this hot vapor refrigerant is introduced into the condenser, and in this condenser warm water from the severe is which is water from this city main line is introduced into the condenser, and where heat exchange between the refrigerant and the water takes place, and this hot vapor refrigerant is converted into the liquid vapor liquid refrigerant. So you are finding that the water from the city main line is extracting the heat from the condenser, and which is converted into the warm water because it extracting the heat from the refrigerant, and this hot water refrigerant is converted into the liquid refrigerant. So this is the water cooled condenser system. Now next is the recirculated water system. In this recirculated water system, we are using the liquid water again and again. So if you observe in this figure, vapor refrigerant from the evaporator coming into the compressor, and in this compressor we are finding that it is converted into the hot vapor refrigerant, and this hot vapor refrigerant is introduced inside the condenser. So what happen in this condenser? In this condenser, there is a heat exchange between this hot vapor refrigerant and the water. So here you are observing that hot water refrigerant is converted into the liquid refrigerant, which is which is uh, collected in the receiver. So this is the path of the refrigerant. But what is the path of the other, that is the water. If you observe, the water is cold water is introduced inside the condenser and which extract the heat from the refrigerant and which is converted into the warm water, and this warm water is again spread into the cooling tower. So in this cooling tower, this is converted into the cold water, and if there is certain loss of the water or there is quantity is become less of this water, then makeup water should be added over there. So this water is going to the condenser water pump, and this condenser water pump increasing the pressure and which is introduced inside the condensers. This is recirculating water because this water is used again and again. So that's why this is called as the recirculated water system. And in this system, we are using the water once and again we are leaving that water. So this is the waste water we are using for such type of the cooling. So this system is called as the waste water system, and in this system recirculation of the water again and again. So this is called as the recirculate water system. So now next we are going to discuss the types of water cooled condenser. In these types of the water cooled condenser, tubing tube type, double tube condenser, shell and coil condenser, shell and tube condenser. So these are the types of the water cooled condenser. So out of this, first we are going to see the tubing tube condenser or double tube condenser. So it consists of the two concentric cylinder tubes, one inside the other. So water is taken into the inside tube from the inner side of the tube, and the refrigerant vapor are made to flow from the opposite direction in the annular space between the two tubes. So due to the counterflow heat exchanger design, maximum amount of the heat is taken out, and this can be achieved due to the temperature difference between the inlet and the outlet water. And this double tube type condenser find their maximum application as booster condenser for meeting peak load demand in conjunction with the chassis mounted air cooled condenser. They require a separate receiver for storing the condenser liquid over there. So the size of the liquid line between the condenser and the receiver should be large than the liquid line leaving the receiver to permit the free drainage and allow the recondensation of the entrapped vapor over there. So second is the shell and the coil condenser. If you observe here, one shell we are using, and in this shell, coils are provided. So in the shell, the if you observe, the refrigerant will be flow, and in these coils, the cold water is the flowing. So as we are saying, it consists of the welded steel shell and one or more bare or finned tubes or coils placed inside each. So the condensing water is circulated through the coil. And in such type of the system, overcharging of the refrigerant should be avoided. So shell and coil condenser are fabricated from small and medium condenser lies. So in its simplicity of the construction and high overall heat transfer, so these are due to the curvature we are finding. So this is the shell and coil condenser. So next is the shell and tube condenser. So these are similar in construction with the flooded type chillers. So number of the straight copper tubes with integral fins are placed parallel to each other, and eccentric fusion. If you observe eccentric fusion, we are providing. So what happened? The tube supports are provided in the shell to avoid the sagging of the tube, and water is circulated through these tubes over here, and the refrigerant centers at the top and gets cooled and condensed as it comes in contact with the water tubes. So this water is coming from the cooling tower or the pond over there. So the condensed liquid is drained off from the bottom of here. So the bottom portion of the condenser serves as the liquid receiver. So in such case, it is designed for receiving 125% of the refrigerant as compared to design the charge amount. So in some condensers, extra rows of water tubes are provided at the lower end of the subcooling the refrigerant, which is below the condensing temperature. So this is the shell and tube type condenser. And last one is the evaporative condenser. So in the evaporative condenser, these are used in the both air and water condensing medium. So to condense the hot vapor refrigerant. So these are these condensers perform the combined function of water cooled condenser and cooling tower. So in its operation, the water is pumped up from the sump, and this water is pumped up from the sump and which is spread over this line. And here you can observe the refrigerant vapor is flowing over here in these tubes, and there is a contact with thermal contact between the liquid vapor refrigerant and the water flowing. So there is the exchange of the heat. So cold water is become warmer and which falls over these tubes, and these refrigerant vapors are converted into the liquid refrigerants, and these comes out from these tubes. So the heat transfer from the refrigerant through the condensing tubes walls and into the water is wetting the outside surface of the tubes, and that's why we are providing the fan over there. A fan draws the air from the here, and these due to that condenser and the discharge out at the top of the condenser, and the air causes from the water surface condensing coil to the evaporative and absorb the latent heat of evaporation. So the cold water drops over here, and there is a exchange of the heat occurs. So these all about the condensers as we have discussed. So in today's parts we have discussed the what is meant by condenser. Next we have discussed the how the condensers are classified in air cooled condenser, water cooled condenser. So these all about the today's lecture. Thank you.